Differential equations, type 2 real-world power. So in 2008, question 10b, we have an example here of power. We have a train of mass 200 tonnes moving along a straight level track against a resistance of 400 v squared, where v in metres per second is the speed of the train. We're told the engine exerts a power of p in kilowatts, and we're told the acceleration of the train is 8,000 minus v cubed over 500 v. And the first thing it wants us to do here is to find the value of p. So let's write down everything we know first of all. So we know that the mass is 200 tonnes, and therefore that's 200,000 kilograms. In other words, there's 1,000 kilograms in a tonne. We have P is our power, and that's going to be P in kilowatts. So therefore that's basically going to be 1,000 P in watts. We have the resistance of 400 V squared, and that'll be in newtons because resistance is a force. And we also know the acceleration is 8,000 minus v cubed over 500 v. So what do we know about power? Well, let's look at our maths tables. And if we go to page 55 in our maths tables, we can see power. And we normally know from physics that power is work over time. But we can also see here that power is equal to force times velocity. So what's the driving force here? Well, our driving force is our tractive force, which is from the engine, driving the car forward. But of course, that's not the only force here. We have another force, and that's the resistive force. So we're going to have to look at our net forces here. So let's get our tractive force on its own first of all. So T is equal to P over V. But of course, P is 1,000 P. So our power is 1,000 P divided by our velocity. If we have the tractive force driving the car forward, my lovely cars, we have our tractive force driving it forward, but we then have our resistive force opposing the motion of that car. So therefore we can say from F equals ma, and therefore if the car is accelerating in this direction to the right, then the leading force will be our tractive force minus our opposing force, which would be our resistance, and that will equal our mass times our acceleration. So we have our tractive force in terms of P there, so that's 1,000 P over V, minus the resistance, which we are told is 400 V squared, is equal to the mass, which we've written down as 200,000 kilograms, times the acceleration, and we're given our acceleration as 8,000 minus V cubed over 500 V. So if I simplify that, I'll be able to get P on its own. So let me multiply across by V there to eliminate my fraction here. So we have 1,000 P minus 400 V cubed is equal to, well, 500 will go into 200,000, and that's 400 times. And if I'm multiplying across by V, well, V will go into V once. So that leaves me with 400 times 8,000 minus V cubed. So let's rearrange and get rid of our brackets. So we have 1,000 P is equal to 400 V cubed plus 400 times 8,000 is 3,200,000. And then we have minus 400 V cubed, which is really nice because obviously 400v cubed and minus 400v cubed is going to cancel, which means I now have 1000p is equal to 3,200,000, and dividing across by 1000 means I can actually find my value for p. So p is 3,200. So we were getting 5 marks for working out our value for power. And that was the first part of the question. So now if I look at the second part of the question, it says, well, the train travels a distance of 69.07 meters while its speed increases from 10 meters per second to v1 meters per second. And we have to find the value of v1. Okay, so we know our acceleration is equal to 8,000 minus v cubed over 500v. So we need to decide, are we letting a equal dv dt or v dv ds? But we can see there that our limits are in terms of velocity and we're looking at distance travelled. So therefore we're going to use acceleration as v dv ds, so that we have velocity and distance in there. And then what I need to do is rearrange my equation here so that I get all my v's to one side and my s's to the other side. So multiplying across there by 500v, we end up with 500 v squared divided by 8,000 minus v cubed, that's dv, is equal to ds. And therefore we look at our start limits and our end limits and set up our integration. So what do we know at the start? Well, at the start we know the displacement would be 0 and the initial velocity is 10. And our end, our displacement is 69.07 meters and the velocity is going to be v1. So our upper limits are our end limits and our start limits are our lower limits. And here we'll have to use a little bit of substitution on the left-hand side here, because it's not a linear denominator, it's not a tan inverse function. So I'm going to say if u is equal to 8,000 minus v cubed, then du dv will equal minus 3v squared, and therefore du is equal to minus 3v squared dv. So in other words, we have minus a third du is equal to v squared dv. So therefore that can then become, and I'll sub back in for my v at the end here with my limits. So let's just integrate. So if we take out the 500, we're left with 1 over 8,000 minus v cubed, which is going to be 1 over u. Our dv is going to become, or take out our v squared dv, and that's going to become minus the third du. And the right hand side is fine. So therefore that's going to become v1 10. So that's going to become minus 500 over 3 times 1 over u du. And if I integrate, that's going to be minus 500 over 3 natural log of u is equal to s in the limits of 69.07 and 0. And of course I have to sub back in for u. And if I sub back in for u, that's 8,000 minus v cubed. In the limits of v1 and 10. So always making sure you're subbing back in. If you're not going to change your limits, sub back in your limits at the end. Okay, so subbing in our limits then, we have minus 500 over 3, natural log of 8,000 minus v1 cubed, minus 500 over 3, natural log of 8,000 minus 10 cubed, and that equals 69.07. So simplifying that then, we have minus 500 over 3, natural log of 8,000 minus v1 cubed, plus 500 over 3, natural log of 8,000 minus 1,000, so 7,000, is equal to 69.07. And then I can write that as one fraction. So let me just switch sides here because we have plus and minus. So that's going to be natural log of 7,000 minus 500 over 3, natural log 8,000 minus v1 cubed, just so you can see your log rules there. So if I'm subtracting my logs, I'm going to divide. So if I take out 500 over 3 out as there as being common, then that's going to be natural log of 7,000 divided by 8,000 minus v1 cubed. And that equals 69.07. So if I multiply across by 3 and divide across by 500, and then we'll have to change from logs back to exponential. Remembering that natural log is log to the base e. So therefore that's going to be 7,000 over 8,000 minus v1 cubed is equal to e to the power of 207.21 over 500. And then I want to rearrange to get v1 on its own here. So therefore, if I invert that, that's going to be 8,000 minus v1 cubed over 7,000 is equal to 1 over e to the power of 207.21 over 500. Multiply across by 7,000. And then subtract. And then get the cube root of both sides. And that gives us a value of 15 meters per second. So if we look at our marks, we had 5 for setting up our v to vds, so choosing the right equation, 5 setting up our integrand, 5 for integrating, and 5 for our answer. So 5, 10, 15, 5 for the answer.